Good evening, all of you. Let's wait 2 minutes. Okay. Are you listening me? My voice is proper to you. Please respond. Okay, thank you. So let's start. This is third assignment. Here we will discuss the question on the Miller indices and crystallography and coordination number. So let's start the first question. This is the first question. The multiplicity of the HKL like HK0 plane in the cubic system will be 48, 24, 16, or 8? So please try to answer this question. Let me take you 1001. Let's say this is the multiplicity means like arranging the these are the possible ways. So you have to try with HK0. So please try to think. So answer is B. So let's see by the lecture. You can see HKL has 48, HK0 24, or HHL also 24. If only three are the same, multiplicity will be 8 only. In the similar way, you have to take example and rearrange the HKL. Should not be repeat. Just change the position. It will be 24. Please try to solve out this question on the home as a homework. If you not get, then we will again discuss. Clear? Just you have to arrange the HKL in the different ways, and which is known as a multiplicity. Let's discuss this question. Second question: which of the following is true? Is or are true for Miller indices of crystallographic planes and direction? Let's read the first option. All the parallel equidistance plane must have the different Miller indices. True. We have to find out the true options. A plane parallel to one of the coordinate axis has an intercept at infinity on that axis. If the Miller indices of the two planes are 1 to 1 and 2 4 4, the planes are parallel to each other. All the planes and direction in a cubic system are orthogonal to each other. Yes, please, which option are true or which option are false? Let me explain. A plane parallel, let me explain first B. A plane parallel to one of the coordinate axis has an intercept at infinity on that axis. Let's say x, y, and g axis, and it's a plane in a parallel plane, one of the coordinate axis. Let me take a plane which is parallel to the z axis, g axis, only in xy, parallel to the z g axis, never cut to the g axis. z-axis or clear, cut at infinity, or we can say. So this is true option. And if the Miller indices, the two planes, these are parallel to each other, which plane are parallel to each other? And A and C similar. All the parallel equidistant plane must have the different Miller indices. Let me create. This B option is clear to you. Now discuss another. All the parallel equidistance plane must have different Miller indices. Let me take two planes. This is 1, 1, 1, and this is half, half, and half. And similar in the way, you can also create planes. Let's cut here, which is one half, one and half, one and half, one and half, and another two also, two, two, two. This is the x, y, and z axis cut, and distance are, they are equidistant. Okay, so what is the now option? All the parallel equidistant must have different Miller indices. So try to solve. Let's say one is 1, 1, 1. This is x, y, z axis intercept, and one is half, half, half. Then check the Miller indices of these two. Please find out. Try convert into Miller indices. Miller indices also take reciprocal and simplest form. Okay, for that 2, 2, 2. You can divide by smallest number or multiply. So you can see all the parallel equidistant plane must have different Miller indices. No, will be same. And last option, if all the plane and direction in a cubic system are orthogonal to each other. And C option, if the Miller indices of two plane 1 to 1 and 2, 4, 4 plane are parallel to each other. No, we can see vice versa. Parallel planes means like that. Just equidistance plane, you can say. So please check the answer now. If equidistance plane or parallel to each other plane, Miller indices will be same. And in cube, Direction in Direction and planes in a cube system are orthogonal to each other. They form 90-degree angle to each other. So clear to this question to you. Let's move for next question. This is the third question. Please read. Uh, what are the Miller indices of, of the plane that make intercept x 3, 2, and 1 angstrom on the xyz axis, crystallographic axis, respectively on the orthorhombic crystal with ABC are 3 is to 1, 3 is to 2 is to 1. Find the HKL. This is the question. Intercept at 3, 2, and 1. Please try to solve this question. How can you find the Miller indices? One question will be asked in exam, definitely, on the Miller indices. So please try to solve. We discussed in the last class how to determine the Miller indices of the planes if the intercept are given. Take 5 minutes and try to solve this question. Then I will discuss. So are you able to do? Let me explain. First step, intercept 3, 2, 1. Then reciprocal of these intercept and with ABC, let's say 3 time on x-axis, 2 time on b-axis, 1 time on c-axis, and okay, with their orthorhombic crystal system means A, B, C are 3, 2, and 1. So these are cancel out. This is 1, 1, and 1. Already in simplest form. So C will be the answer. Just simple reciprocal of the these intercept, and with ABC also is given, so you can put like that 3 is to 3, 2 by 2, and 1 by 1, 1, 1, 1. Next question: which of the following represent the correct Miller-Bravis indices in the hexagonal system? Which A, B, C, D? Which option is correct? Please try to choose the right option. 4 hexagonal. So answer will be C. Please remember, this is the notation for hexagonal. Simple HKL, but in the hexagonal system, HKIL. Next, in the Miller-Bravis system, the third index I is for hexagonal system. I always 0, the same as L, redundant, and equal to minus in bracket H plus K. HKIL. How you calculate the I? Which option will be correct, please? So answer will be D. Please remember, this is the formula for to calculate HKL for hexagonal system. Now the question: which of the following plane is parallel to the C axis in a hexagonal crystal system? C axis means C axis, if C axis this, should not be cut by the crystal system, hexagonal crystal system, parallel to the C axis also. This is HKLI, HKIL, all these. If let me let's say H equal to 0 means 1 upon 0. How to find out the infinity? Intercept at infinity. So C axis, which represent by, let me discuss. Answer B is correct. C axis represent by L for here hexagonal system. If A is not correct, why? L should be 0. Should not be cut on the C axis. Cut at the infinity. This is the condition. L should be 0. And what about the other? So explanation is 1 minute. In a hexagonal Miller-Davis system HKIL, the fourth index IL represents the intercept with the C-axis. Okay, as we discussed, if a plane is parallel to C-axis, it does not cut on it. So L equal to 0. Next question also, the plane 0, 0, 1 in a hexagonal system is parallel to axis, parallel to basal plane, perpendicular to c-axis, intersect at three axis equally. 0, 0, 0, 1. So here we answer will be the parallel to the basal plane. This is basal plane 0, 0, 0 and parallel to this plane. So these are question for the hexagonal crystal system. Next question, which of the following set of Miller-Davis indices is correctly written for a plane in a hexagonal crystal system? Yes, please, correctly written. You have to find, check this, which one is correct or not. Then you will be able to find the answer. Please try yourself this. This is simple question. You have to just verify this relation. Try to solve this question. So these are not simple, easiest. Only three Miller indices are given. This is 4 and check this relation also. H1 case 0, it would be -1. Is given. -1 also. Okay, so this is B's correct answer. Now next question, the angle between the direction in a cubic system. Please find out the theta. Let's say UVW. So U1, U2, a2 square, b2 square, and w2 square. Please find out this. You will able to now find out the theta. You can take 5 minutes for this calculation. Please try and give me the answer. Take 5 minutes for this equation to solve. So now please put the value. This is let's say 111, and please put this value in this equation. 1 cross 1 plus 2 cross minus 1, 3 cross 1, 1 square, 2 square, 3 square, 1 square, minus 1 square, again 1 square. It would be 1 minus 2 plus 3, 9, 4, and this is 10, and 4, 14, 3, 2 by. Please solve out this. Take the inverse, cosine inverse 2 by root 42. Find out the theta. So answer will be 72. This theta for this value 2 by root 42 will be 42. So 72. Okay, let's next discuss next question. Which of the following is true for the crystalline solids? They have very varying bond energy between the atom. They have long range periodicity. They give sharp diffraction pattern. The atom are mainly bounded via secondary bond. Yes, please. Which option is correct? Try to choose the option. Then let me see. Answer is they have long range periodicity and they give sharp diffraction pattern. While you can see from the lecture, crystalline, long range periodicity, sharp diffraction pattern, has sharp melting point. That's why high density. Non crystalline, no long range periodicity, doesn't give sharp diffraction pattern, and sharp doesn't have sharp melting point and lower density. We have discussed already crystalline, non-crystalline in the first assignment. So this is the next question. In a hexagonal system, a plane with Miller indices 1, 2, 3 in 3-digit could be converted into the following Miller-Bravais indices using 4-digit convention. Yes, please find out. H, K, I, L. We have already discussed the formula. Take 2 minutes and try to solve this question. And please choose the correct option after getting the answer. You can do if you know the formula, just you have to calculate just I. As we discussed, I equal to minus H plus K. You have H equal to 1, K equal to 2, L equal to 3. H1 plus K2 would be minus 3. So this will be notation from here, and I also will get H1 K2 I minus 3. So you can write like that, minus bar 3, sorry, 3 bar and 3. This will be the answer. Easy. Minus should be there, not here. As we discussed, let me show you. Minus H plus K and HKIL. Okay. So B is the correct answer. Next question, answer is already given, but try to solve out this. In a hexagonal system, Miller indices in the direction Miller indices of the direction -2, -1, and 1 in 3-digit convention would be converted into following Miller index could using 4-digit convention. Now please give me this is correct or not. Answer. 4. This is direction, not HKL. This is not this. This bracket is here, a square bracket. HKL represented by if given like that. This bracket. So let's see the procedure. In 4 digit U, V, T, and W. For the direction, you can follow these. You have U, V, W here. Now please put this value and try to get this answer. Let me put 1 over 3, 2 into U minus 2 V minus 1 for V 1 over 3, 2 into V T U plus V and W equal to W, which is 1. This is 4 minus 4 plus 1, 3 minus 1 equal to minus 1, and V equal to minus 2 plus 2, 0. So T would be plus 1 and W equal to 1. So minus 1, 0, 1 and 1. Okay, clear this answer explanation. So you have to need, please remember this formulas. Let's discuss 13 question. What is the coordination number of the atom in case closed packed monoatomic structure? 4, 6, 8, 12. Which option will be correct? So let's see. Answer is 12. Please see the picture one by one. Below has this yellowish layer, monoatomic structure. So this is 1, 2, 3. This atom touched by these 3 below atoms. Okay. Now let's move forward further. In the same layer of this atom, this 3 is below, 4, 5, 6, 7, 8, 9, and top of all this is a, if the atom, this is a also, this is a type atoms. So sorry, how many atoms touched by this atom is 12. That's why coordination number is 12. Next, the atomic position of a centered cubic unit cell are. For the abscissa lattice, let me make X, Y, Z. Coordinate of XY center is 0, 0, here 0, 0, 0, and F. You can take three adjacent cubes like this one, then this two, and below is three. They are nearest cubes. So position of the centered atom on the cube is, what is the position? If this is A, will be at half. For this corner 0, 0, 0, rest of 3, let me write down this. On the Z and axis, this plane, this last. On the Z and Y axis, so X will be 0, Y has half, Z also has half. For this X and Y, so half, half Z 0, and for that Y will be 0, X and Z. So which option is correct now? B. Getted my point? We have to choose the adjacent faces and position of the center, because atom sit can the center of the face. Which of the following best describe the hexagonal closed cube pack structure? Non-primitive lattice with the motif at 0, 0. Non-primitive lattice with the motif at 0, 0, comma 1/3, 2/3 and half. Primitive, primitive lattice with the motif at 0, 0, and primitive lattice is motif at 0, 0, 0 and 1/3, 2/3 and half. So C, answer is D, primitive lattice. You can see this is taken by the from the lecture. Mod 0, 0, 0, motif at 0, 0, 0, and for which system? Hexagonal. Here is the define the number 1/3, 2/3 and half. Okay. So see the lecture also. As a face-centered cubic lattice has closed cube direction along this abscissa cubic lattice. Closed cube direction along 110, closed cube peg along with 111, and closed cube peg along the 110. Direction and closed peg planes along. So closed cube direction along 110 and closed cube plane alone. One is direction, other is plane for the abscissa lattice. Abscissa, you can see this is the planes and direction. one close Q peak direction this and planes there. HCP you can also see these are the options. Next question, the correct relation between the lattice parameter A and the atomic radius R in the body center. These are the four options ABCD. Please try to solve out these options. You can take 5 minutes for this question. Any answer? So let's try to solve the correct relation between the lattice parameter and the atomic radius. No, body centered. 2D centered cube. One atom at body, other are at faces, corner, sorry. So they are touched by body diagonal. So you have to find out the diagonal of the cube. If lattice parameter is given by A and radius is R. So how can you find out? Let me tell you. This is the cube and body diagonal. Let's see. This will be the body diagonal. So this is A, B, C, D. Let's see, and E. In the below phase, diagonal of this cube A, B, C, and E. This is A, this is A, and they form a 90 degree. So this will be root 2 A. Okay, this is root 2A, and this is also A. They form 90. So this is 90. This is root 2A. This is A. What would be the diagonal? AD. Solving after this, 2A square, 3A square, taking root 3A. Okay, this will be root 3A. And how many R's if they are touched by diagonally? A to A. This is R, this is R, R and R, 2R. This is 4R equal to root 3A. A equal to now 4R by root 3. Which option is correct? A. Clear? Let's move for next question. Hexagonal closed cube structure is described by the sticking sequence ABC, 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 or AB, 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 ABC, AB, or BC, BC, BC. So answer is AB, 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 and BC, BC, BC. This is the for close hexagonal close peg AB, 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 or we can written AB, AB like BC, BC. First layer A, second layer B, third layer C, again A, or if cube is cubic close peg stuck, then third layer will be C, otherwise they will be A. Or we can let B, C, then again B. So BC, BC, BC. If starting from AB, then AB, AB. Next question, which of the following direction is are common to the planes 1, 1, 1 and 1 minus 2 and 1? Which of the following directions are common to the plane? Common to the plane 1, 1, 1. How can you find out the common direction of these two planes? So C for a direction UVW lying in a plane HKL should give the H dot U K dot V LW equal to 0. Okay, so you have two HKL and now you have to find U, V and W. You can take 5 minutes for this question. Please try to yourself first. Do the calculation. All are given here. So how can you find out from this equation? Please put first form the equation 1 U U V W, that's equal to 0. Second one U minus 2V W equal to 0. So you have to this equation 2. Now please find out the UVW. Just minus this equation minus 3V equal to 0 means V equal to 0. So D will be not the correct answer and A will not be correct answer. After put V U equal to 0, V equal to minus W. So one is positive, other is reciprocal of this. So minus 1 0 minus 1 will be the answer. Or if we want to make other, this could be also a minus 1 0 1. So B and C correct answer if this is should be 1. Okay. Next question. Find out the family of planes 1 0 0 and draw. So we can also 1 0 0 0 1 comma, we can also insert minus 1 0 0. How can you draw? Let's see. On the x-axis, cut at x-axis parallel to y and z. So this is x, y, and z. So this is the 1 0 0 plane. Now cutting on the y-axis, this is y equal to a, air is cut. So this will be the 1 0 1 z axis, cut on the z axis, z axis. So air is the cut. So making the plane, this is 0 0 1. Similar, this is x axis, y axis, and z axis. So this is minus 1. After making this is minus 1 0 0. Similar minus y. Let's choose. Let's say x, y, and z. So this is minus y. And minus z, x, y, and z. So this will be minus z. Okay. In this way, you can shift the origin and decide the next question. Find out the common direction between these triclinic units. So similar way, you have to solve out the equation. HKL are given. So U, V, W equal to 0. Other 0 U, 0 V, W. So here W is 0. Now U V equal to 0. U equal to minus V time. So choose the option now. Which option is correct and which is not correct? See, one is positive, one other is negative, and W will be 0. So only A is the correct option that you can see. After solving this equation, first and second, you will get the answer. Okay, for so common direction, you have to follow the equation. Let me write down. If UVW, you have the direction and has the HKL. So U, H1, HK, UV, and W, HKL. First equation will be this. If HKL, H1K1, comma, HK2L2 are given. Then second equation will be this. Okay, please put the value in this equation, then you will able to solve this type of question. Clear? Please see, and if it, are you getting, then we will move on next question. Please see. Clear to you? If I have any doubt, let me know. Otherwise, let's move if you don't have any doubt. Or another way of solving this equation, 1 minute, just this is after solving, you will get like that equation. So this is the way, and after solving, you will get UVW in this way. Okay, so let me show you another. HKL, HK1 are given, HKL to 0. After putting in this equation, also we get the similar answer. A. Okay. So next question, does the direction lie in this plane? Please check. How can you decide this direction lie in this plane? Just verify the last equation as we discussed here. For a direction lie in the plane, this is the rule. Multiply HKL with UVW. Sum of these should be 0. So please check this for this question. You can take 2 minutes, 2 to 5 minutes for this question. Please check out yourself, then I will discuss. So let's check the option. You have given U, V, and W. 1 minus 1 as 0. And HKL 1, 1, 1 are given. U, H, K, L will be 0 if they lie, direction lie in the plane 1 into 1 minus 1 into 1 0 into 1 1 minus 1 will be 0 minus 1 equal to 0. Okay, so yes, lie. Yes, okay, you can check the solution. See, also we can see if the direction lie in the plane, they are perpendicular to the normal of the plane. So that's why this is the rule. Next question. Does the 1 minus 2 direction lie in the 3 0 minus 1 plane? Now please check yourself. You have UVW direction and HKL plane. Check yourself. Let's say this is the plane and direction also lie in this UVW. So normal of this plane will be make 90 degree. HKL plane. So HK will be 0. So please try to this equation and solve and give me the answer yes or no. Yes, please check out yourself. You can take 2 minutes for this calculation. So now please put, let's solve this equation. U, you have given V and W, as well as put this value in this equation and check 3, 0 minus 2 equal to 1, not equal to 0. So this direction doesn't lie, no, doesn't lie in this plane. Okay, doesn't lie. Next question. Which of the following statement about the 2, 1, 4, 2, 4, 1 and 2 minus 4, 1 plane is false? They are perpendicular, they are part of the same set of plane, they are part of the same family of plane, they are called parallel, which is false. So we know 2, 4 and 1 family of and set of planes, we can replace minus also, and family of planes are parallel. So this is right all, but this is correct statement. False statement this. Okay, so that's why this is false statement. That's why this is the correct answer according to the this question. Okay, so this is all about today. If you have any doubt, you can ask. Thanks for your kind attention. We will meet next Monday with fourth assignment.